This is part 1 of our lesson on logarithmic function review. So our first question here says, for the function f of x equals log base 7 of x, evaluate each of the following. So evaluate means calculate. We actually want to have a number answer. So our first question is f at 16,807. So what this means is we are going to take our equation f of x equals log base 7 of x, and everywhere I see an x, we are going to put in 16,807. So this is going to equal log base 7 of 16,807. Now to do that, there are multiple ways to calculate it. The one I like the best is using our yellow reference package. So I would look at my list of common powers, and a log is asking the question, 7 to what power equals 16,807? So I want to look at my powers of 7, and I want to look for that number. So I do see my powers of 7 here, and I notice 16,807 is 7 to the power of 5. So I'm just going to replace 16,807 with 7 to the power of 5. So when I ask the question, 7 to what power gives me 7 to the power of 5, the answer is 5. 7 to the power of 5 equals 16,807. Now, you do not need to do that middle step where we write the power in. You could just look it up and then answer 5, but I like to put that extra step in as part of my lesson. Our second question says f at 1 over 49. Same thing as last time. We are doing log base 7 of x, and in place of x, we are putting 1 over 49. So this is going to become log base 7 of 1 over 49. If I go back to that yellow sheet with my powers of 7, I see 49 is 7 to the power of 2. But it's not just a 49, it is 1 over 49, so it's a fraction. Negative exponents make fractions. So I know that the exponent on the 7 has to be a negative number because my answer here, the argument, is a fraction. So this is log base 7 of 7 to the power of 49 is 2, so negative 2 because it's a fraction, which means this just equals negative 2. Our last example in this question says f at 876. So what I'm going to do, same thing as last time, is put that in for x and do log base 7 of 876. Now if I look at my list of powers of 7, you will notice 876 is not on this list. It would be somewhere in between 343, which is 7 to the power of 3, and 2,401, which is 7 to the power of 4. So this tells me that it is going to be 3 point something. So it's going to be a decimal in between 3 and 4. So I could guess and check, but I would rather just calculate. And in order to do that, I am going to use the change of base formula. So in our yellow package on a different page, we have an identity sheet, and there's a section on exponent laws, and there's a section on log rules. So there is a log rule that says log base b of x equals log base a of x over log base a of b, which is basically just a change of base formula. So if I want to change the base from one to another, this is the formula that I would use. Now, my calculator that I have cannot do log of any base. It can only do 2 different types of logs. It has a button that just says log, that is log base 10, and it has a button that says ln, which is log base e. So I'm going to try to convert my log base 7 of 876, into either log base 10 log or log base e ln. I personally like ln, but you're welcome to use log if you would prefer. So I'm going to say this is ln of the original argument, that is 876, divided by ln of the original base, which is 7. The other option that you could do is you could do log of 876 over log of 7. You also might have a button on your calculator that will do it for you, which is fantastic, but I do not. So I'm about to calculate ln of 876 divided by ln of 7. And I got 3.481849403, or it does ask in the question for us to round to 2 decimal places. That would be approximately 3.48. And just to show you, if I did log instead of ln, so if I did 876, and I did the log of that, and I divided by log of 7, I also got 3.481849403. So I did get the same answer. All right, so that's it for question 1. I will see you in the next video to do question number 2.